Page 3 of your final exam review. Find all real zeros of the function, give exact values when possible, identify each zero as rational or irrational. Okay, so we start off with this function. It's given as x cubed plus 4x squared minus 5x minus 20. They want to know the real zeros, so they want to know when this function is equal to 0. Yes, it is a factor by grouping question. There's this one subtle move I really encourage students to do. Okay, because that's where we're going to factor by grouping around. So we don't like to factor around minus signs. We like to factor around plus signs. So we'll turn that minus into the addition of a negative number. Note the use of parentheses. Okay, with that plus sign there, we're ready to rock. We got our parentheses around our into our groups, I should say. Let's factor out the highest power here. So that's x plus 4 plus, notice I'm going to factor out a negative 5 here, and what's left over is an x plus 4 is equal to 0. Be careful, make sure you redistribute, make sure you're getting the values that you like, and just realize that you won because these guys match. So let's factor out the x plus 4, and we write the x squared minus 5, and we know that equals 0. So the zero product property says x plus 4 is equal to 0, or x squared minus 5 is equal to 0. And with that, we know x is equal to negative 4, or x squared is equal to 5, or x is equal to plus or minus the square root of 5. So x equals negative 4, which we'll say is rational, okay, because that's an exact value. And then x is equal to plus or minus square root of 5, which are both irrational, non-repeating decimal, and also a number that cannot be represented as a fraction. Okay, let's keep going here. Number 15, for the given function, find the horizontal asymptotes. All right, so there's some rules here. Remember, if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is y is equal to 0. If the degree of the highest numerator is equal, that's this case here, to the one in the bottom, then y is equal to a over b. We also see that when n is greater than m, we know that there is no horizontal asymptote. Okay, so our case is this one here. So 6 over 6 is equal to 1. So y is equal to 1 is your horizontal asymptote. Remember, just grab the coefficients when the powers are matched. If the power up top is greater than the bottom, there's none. If it's less, then it's at 0. Okay, so the only time you're really getting something other than 0 is when they're equal, and when the top is bigger than the bottom, there's none, and when the bottom is less than the top, there's 1 at 0. Okay, match the graph of the rational function with its equation. Okay, so you can spend some time graphing these if you want, but graphing is, you have to develop an eye for it. And I see a y-intercept, and it looks like the y-intercept's somewhere around 1/2. So let's set each of these guys equal to 0, because if we want to find the y-intercept, always set, to find the y-intercept, okay, find the y-intercept. Okay, it's a nice quick way to get out of this problem. Set x is equal to 0. So f of 0 over here would be 0 plus 1 over 0 squared plus 0 minus 2, and that would give me a negative 1/2. And that looks pretty good. Let's go check out this guy over here, see if my plan worked. 0 minus 1, 0 squared plus 0 minus 2 would give me a positive 1/2, because two negatives make a positive. So here, just because of where the y-intercept is, and I had to choose between these two functions, what you could have done, okay, what you would have to do if you wanted to graph this guy is you would take x squared plus x minus 2, and you would factor it, and you'd see that there were horizontal lines at, what's the answer here? So a -2 and a +1. You could see that the power up top is less than the power at the bottom, so y is equal to 0. And then you'd have to start, plugging points in to get, other points. But there's a nice quick way, because at some point you're going to set x is equal to 0, and you'll see that graph here is equal to the one where you get -1/2 when x is equal to 0. So that was the idea, but if you know this process well, you can just skip all the way to that part just to find the intercepts. There are always major parts of graphs. Did I do the same one twice? I did. So let's not do it twice. All right, down to my favorite, logarithms. So the best thing to know about these are, how do I write this? So I always say something like log of base a of b to the c is, there's so many log rules. So how do I get you to evaluate this one? So let's just pretend we see this. So log of a b to the c is equal to d means that logarithm is an exponent. That's the base. I don't need that up there. That would make life confusing for you. I understand. So this means that a to the d is equal to b. I think I have better formulas out there. That doesn't look as smooth. But the idea is that an exponent is always a power. So a to the d is equal to b there. So if we look at this here now, we have log base 8 of 32 is equal to x. So we don't know what it is. Just call it something. So that means 8 to the x, because the logarithm is an exponent, is equal to 32. Oh, and I probably do some math here. So I think it's 2 to the third is equal to x. And, I don't know, what is this? 2 to the fourth or something? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's to the fifth. So you raise a power to a power, you multiply 2 to the fifth, and using the 1-to-1 property, 1 to 1, you get 3x is equal to 5, or x is equal to 5/3. Yeah, I'm just trying to think about all the different rules you probably need to know for logarithms. So yeah, they're in my notes. You can look them up on Classroom Google too. You'll look under the topic for logarithm, take a look at the notes. Just glance them over, refresh your memory on all of those. All right, let's see if we can do something here. All right, so ln of 1 over the square root of e to the third. I want us to kind of grow up here, and you have to write e to the third to the 1/2, all right? And then if you raise a power to a power, you multiply. So that's 1 over e to the 3/2. And then if you bring him upstairs, you get ln of e to the -3/2, and we know that the property of ln of e is equal to 1, so we'll use that, and we'll just write it equal to -3/2. Okay, again, if you're having problems with logarithms, you know what to do. Go hit up the Khan and just type in logarithms and just refresh yourself on all those rules. I have a feeling that some people just got to go over their rules. I used a bunch of them in here. All right, so yeah, here we go again. So again, Khan's going to be your best friend in these situations here. Not a bad idea. Log of the 5th root of x over y. Good luck. How would I rewrite this one? Yeah, this is mean. So I probably start off as log of x over y to the 1/5. That's how we turn radicals into rational exponents, and that's equal to 1/5 log of x over y. Oh, a mean one too. You got to be careful with your parentheses. So then that's 1/5 log, using properties, of x minus log of y. And that would be good enough for me. If you wanted to distribute, just to prove that you understood the use of parentheses, you might have to go the whole way on a multiple choice question. So be careful with that there. Okay, is that it? Oh, great. Record time? I don't know. So that was page 3, and I'm calling that one done. Is that page 3? I wish I was on page 4. Okay. Let's see if we can keep going. All right.